Hi, cohort.
I really don't know what to say about this week's homework. It's filled with lots and lots and lots of really tedious calculations, which, according to Sheldon's comments in class and according to the study guide that is posted on ANOVA for the final, you don't ever have to know again after getting this homework assignment done. So I leave it to your good judgment how much time you really want to put into mastering all of those really, really tedious calculations that you're going to need just for this homework assignment. What I am going to demonstrate in this video is problem number 12, and just the hypothesis test part of it, to show you how you can use technology to do an ANOVA, and to talk a little bit about what an ANOVA might do. If you have a quantitative part of your dissertation project, it might involve an ANOVA because it's one of the most common statistical tests there is. So that's what I'm going to do. If I have time, I might post another video about the real tedious calculations, but personally, I'm not sure how much really it's good to invest time in that this week, especially when there's so much other stuff we need to get done. Okay, so here we go. And in problem number 12, we have these three programs for phonological awareness, which is, as Eric has told us, is different from morphological awareness. But anyhow, it's these three programs, and we're interested in finding out, do they all produce about the same results? Do they all have about the same mean? Or is one of them possibly different than the others? Okay, so we start with the null hypothesis and alternative hypothesis. So here we go. The null hypothesis is that all the means are the same. In other words, there's three groups, so I'm going to write that mean 1 is equal to mean 2, and that's equal to mean 3. The alternative hypothesis is that at least one of the means is different from the others. Okay. The ANOVA, as we saw in class when it took us 3 hours to do one problem, is one of the most labor-intensive tests there is if you do it by hand, but I'm going to show you how you can do this on a calculator in less than 5 minutes, less than 3 minutes. You can time it. Okay, so here we go. Here's our calculator.
Which is hopefully open.
Open it up. There it goes. Alright. So I'm just going to begin by putting the data into my calculator, and if you're on an iPad or whatever technology you decided to use, you can put in whatever technology you have. So I'm going to put my data into my calculator. Alright, so for the first program, the numbers are 17, 13,
14,
and 10. Okay, for the second program, the numbers are 7,
5, 12, and
8. And finally, for the last program, our numbers are 16, 9,
15,
and 18. Okay.
So our
Data's in our calculator or in whatever technology you're using. Oops, I think this too is messed up. Hold on, let me fix this for a second. So this isn't supposed to be 75, it's really supposed to be just 7, followed by a 5, then a 12, and a 8.
Okay, so now
I think our data sets look good. Alright, so on this calculator, I'm just going to go to Stat, over here to Tests, and the very last one that we're going to find, I think, is probably the ANOVA.
Yep, here it goes.
So we'll select ANOVA. Now what the calculator is asking us is, hey, where's the data? So my data is, first of all, in list 1, comma, list 2, comma, list 3.
And yes,
Really, that's all there is to it. We'll press enter, Tons of stuff there, but remember, whenever you do a hypothesis test, all you're looking for is the test statistic and the p-value. In this case, the test statistic is called an F statistic, so it's 4.59, and here's our p-value right here, 0.04. The significance level in this test, according to the book, is 0.05. 0.04 is less than 0.05, so we're going to reject our answer. So here we go, we're just going to write that all down. So our test statistic, F is equal to 4.59. Our p-value is 0.04. And so our conclusion, we're going to reject our null hypothesis. And our conclusion is evidence suggests at least one of the means is different. Like we talked about in class, the F-test doesn't tell us which mean is different, although we could probably guess which mean is different. Program 2 looks, Assessment Suite would say, not like the others. But to really confirm that, we would need to follow it up with one of the post-hoc tests. Calculator, I don't think, does a post-hoc test, so that we would need a more powerful technology for SPSS, or possibly the iPad app might do it, I'm not sure. And that's all there is to ANOVA. One thing I want to make sure that we're clear about, though, when we do a hypothesis test, this conclusion that we're writing is a conclusion about the program if it was used for all people. Obviously, the means are different for the 12 people that were in the sample. So that's not what we're saying. We're not saying that this sample is different from this one or different from this one. The conclusion to our hypothesis test is much more powerful than that. What we're claiming is that these programs are not all the same, and one of the programs is different, and pretty much we can tell from looking at the numbers in this case that probably program 2 is different than the rest, but again, we would need the post-hoc test to tell. Okay, that's it for ANOVA. Good luck with your homework.